Yeah, so this is the Git Workshop, co-hosted by EWH and EWB. And so what is Git? So there's two things here. There's Git and there's GitHub, both of which well, they work in tandem, but they're a bit different. So what's Git? Well, so Git is a tool for source code management. What that means is that basically when you're building code in some sort of code management system, you want some way to manage all the different code files that you'll be making. Because you might have things like an HTML file to display a website. You might have things like a JavaScript backend to make different parts of the website function. You might have a lot of different parts in a lot of different languages. And so it's useful to have one tool to sort of manage all these different types of coding going on. And Git basically serves that role. It's a code repository. So it's basically somewhere you put your code and you manage it as you update it and add to it. So this means that it sort of allows for easy version control, which is really nice. So if you update the code, it's really, and you make a mistake, you make some sort of bug which messes it up, it's really easy to roll that back, which is great. It's great. And it also has a lot of features which are really good for sort of multi-user convenience. So if more than one person is working on a code base, it's really easy to do. One issue that people run into in programming large projects is that it can be really hard to track what changes you've made to the code and when. It can be hard to figure out what change you made that ended up breaking something later down the line. And a program like Git is nice because it more cleanly sort of allows you to go through different versions of your code and check what works and what doesn't. And yeah, Git is the most popular source code manager, primarily because of its robustness and also in part because of GitHub. But so let's talk about Git first. So there are a lot of common terms used with Git. So the big one you need to know is a repository. So that's the entire collection of like files and folders associated with a project. And as the slides say, that's each file actually has a revision history associated with it that goes back to when the file was first created in the repository. The way different revisions are managed is sort of along these branches. And how these branches basically work is that development doesn't always go down a single track where there's only one set of files. And we'll see a few graphics to make this a bit clearer, but what happens is that you actually branch your code out, you get a branch of it, you make all the changes on this branch, make sure all it works, and then you merge it back into the original branch to sort of complete the cycle of adding a new feature. And the branching system is nice because if you branch something out, fiddle with it, and it all falls apart, well, you can just abandon the branch. You still have the original code. A fork is sort of the same idea. It's just a branch from the original master branch, like the source, basically. Often it's called the master branch or the origin. A commit is just a change you've made to the code. It's a change you've committed to the code base. So this could be on a branch, it could be on the master branch. Yeah, and then a clone. So you're gonna see clones a lot. For instance, if you're using code from a third party on GitHub, say there's some code on GitHub which allows you to really easily like calculate the volume of a sphere and you really want to do that, you might make a clone of that GitHub repository and then basically use that code that you've then taken down to yourself from the cloud or wherever in order to use it yourself. So it's sort of a copy of a remote repository that lives on your local computer. So changes to the clone won't affect the original repository. So these are some of the more common terms that we're going to run into. And so this right here looks complicated, but basically what it's just outlining is the different like sort of levels of commitment to your code you have. So right here we see, let me get the pointer on. Right here we see the local repo. So this is going to be a directory on your folder. So a folder on your folder, somewhere where you put information. That's going to be the local repository. And basically that folder, that directory is going to hold all of the files that you want to keep managed through the Git source code manager. When you make a change to a file in this repository, it's only going to be changed in the working directory until you add it to the staging area and then commit it to the repo. And what that process does is it means it's making a change semi-permanent. I say semi-permanent because you can always roll back these changes, but a bit more permanent. So while you're fiddling with code, trying to get it to work, you're probably moving stuff from the working directory to the staging area. And then once you have something a bit more manageable, you can commit it to the local repo. This local repo might be sort of, so Git checkout is sort of the way to access different branches inside of the local repo. So if you have different versions of your code that you're working on, so one stable version that works, and maybe a new unstable version which you're in the process of creating and testing out, you might check out the unstable version to work on it a bit and to add things to the staging area and then commit them to the local repo. Yeah, so, or you might check out the master branch if you're like done with your fiddling and you're either abandoning the branch or just working on something else. Something like GitHub adds this additional bit of a remote repo. And what that sort of means is that, so a remote repo is basically just a version of your repo on the cloud, so commonly on GitHub. And that means that the code you have saved on your local computer is accessible online and by other users with other computers. And it'll just be saved in this remote repo. And so this has sort of a further level of separation from your local repo. And so in order to move code to the remote repo, you push your branch to the remote repo. And in order to get code from the remote repo, you pull code from the repo. So what are these terms? What is git add, git commit, git push, git pull? What are all of these? So these are all basic Git commands. So when using Git by itself without the use of GitHub or a manager like GitHub Desktop, you basically do it by using specific commands inside of the terminal. So the terminal is the little box where you can type stuff out. You can change your directory. You can do a lot of things from it. And one of the things you can do is you can use Git commands. Yeah, so terminal is one name for that thing. Command line is another name. And so you use these types of commands to interact with your Git repository. Later on, we'll be showing the GitHub Desktop, which basically is nice because it removes the need to know these specific commands and has a really nice to use UI. And it sort of makes this easier, but it's good to sort of know what these terms mean in general, even if you aren't specifically going to be typing them in. So git init stands for initialize. It initializes a brand new Git repository. And so you can either do this in an empty folder, so where you're going to add stuff, or you can do it in a pre-existing directory, and Git will sort of just collect all of those files into its system. And yeah, Git clone is basically creating a local copy of a project that exists already remotely. So that's like, again, like if you want to calculate the volume of a sphere, and that is available online, you might clone that repository onto your local computer. And then Git checkout allows you to switch between branches, basically move from, the in-between branch and the master branch. Yeah, there's this term called a working tree, but it sort of just has to do with that same branch idea. So again, so you'll see how, like, you'll see Git checkout moves you, is checking out different branches. I'll have another graphic though that hopefully will explain the branch structure a bit clearer. So just a few more commands. And again, don't worry too much about the specifics. Try and just sort of get the general idea. So git add stages a change. So again, this isn't you completing your update to the code. This is you sort of having an in-between stage where it's a bit fiddly. So you can stage a change with git add, and then you can commit it, which basically saves a snapshot of the code. And what committing it means is that you can roll back to that point if you make further changes to the code. So staging something is enough to sort of mark your progress, but it isn't enough to revert to if you introduce a bug or something later on. You can convert your code to any previous commit of your Git repository. Git status sort of just shows the status of where files are, so whether they've been added to the staging area or whether they've been committed or whether they've been altered since the last snapshot was saved. Git branch, so that sort of shows the different branches that you're working with. And it can also create a new branch. So you'd use it if you wanted to create a new update or a feature. So Git merge is sort of how you pull those branches that you've changed back into the main one. So if you've finished that update to your code that is stable and you want to incorporate it into the main code base, you would merge the two branches together. And then Git pull and Git push sort of work together in tandem to either push changes to an online repository or pull them from the online repository. So here we can sort of see this Git branch structure. So you'll see the master branch is on top in the green. It has the different version labels. Actually, all of these different nodes are going to have their own version labels and their own comments to sort of describe them. But you can see that, so we had version 0.1 over here. There was a new branch to develop some new features. So this develop branch over here, and this was further branched off to a specific feature that they were working on. So you can see that they sort of committed several times to the feature code that they were working on. And, but it ended up being a dead end. They didn't end up liking what they did in that feature. So they just discarded that branch and moved on from it. Meanwhile, they were developing the develop branch further. They were committing new changes to it. They branched off another feature that they tried. And this time they actually did like it. So they merged it back into the development branch. In the meantime, the master code had an update to version 0.2, a single commit. And it looks like over here, what happened is that they incorporated a new release branch, updated it, and then they basically merged this release branch into the master branch over here. And then, but also branched it simultaneously to continue development on a different branch. And so what this means is that version 0.1 was always there and it was always workable no matter what changes they did over here in development. And the same with version 0.2. And only when all this development had reached a point where the code was stable and usable did it finally get merged back into version 1.0 over here at the end. So now we can start talking a little bit about GitHub in specific. So GitHub is an online server which hosts Git repositories sort of in the cloud. It's incredibly popular. You'll see it references it to it everywhere. Many different projects are sort of hosted on GitHub. There's tons of stuff there. It's nice because it's free to use and it works very well with multiple contributors. So even if, you know, there's a dozen people working on a single code base, it handles it very nicely. And it allows for a lot of access to Git features without explicitly needing to know Git commands just through their website user interface. This is even further pushed by the GitHub desktop application, which basically pushes that UI a step further and incorporates even more Git commands. And yeah, so applications like GitHub desktop make it all even more accessible to use. So this is sort of the structure of like a GitHub online repository. You can see the repository on the server is saved up here. And then each of these workstations would be like someone different working on it. So yeah, we could have Kevin, Steve, and Bob, you know, all working on this single volume of a sphere project. And they're basically pulling from the repository to get to their code here and then working on a working copy until they've, you know, worked on their own repository and then pushing it back to the online server repository. So this is sort of another way of viewing it where you have this push-pull relationship and this commit and then also checkout sort of relationship down here. Yeah, so I've thrown around a lot of technical terms. You might be sort of wondering what this is going to look like day to day as you work on projects. So basically what we have outlined here, I would say would be the biggest takeaway from this workshop. This is the basic workflow you want to follow as you're working on a code base, specifically with multiple users, although it's good practice just generally, even if you're the only person working on the code. And the reason why this workflow is kind of important is because working on a single repository with a lot of people can get really confusing and work can get overwritten if you aren't careful and you're not using source code management like Git and GitHub. So it's good to be consistent with your general workflow. And here's sort of just a basic system on how to keep track of your work and how to keep track of other people's work. So basically, the first thing you're going to do when you have your code and you want to add something new to it is that first you're going to check out the master branch. So that means that you're going to move over to the master branch. And that's not the same as merging. You're just changing your focus from you're not focusing on the sub branches, you're focusing on the master branch. And then you're going to pull any updates from the online repository like GitHub. And what this is going to do is it's going to make sure that the code you're looking at is as up to date as possible. And that's a good first step because a lot of the times if you don't pull and you don't go over to the master branch and pull to that, then a lot of the times you might fall behind with what's happening as other people update the code. So a good first step is to check out the master branch, move over to the master branch, and then update it from the online repository. So next, you're going to want to create a new branch from the master branch. So this is if you're creating a brand new update. Otherwise, if you already have some branch in progress that you're working on, you'll just want to check out that branch and move over to it. But if you're just creating something new, you'll want to branch over to it. And as you're working on that code, you'll begin adding and committing to it. So always in that order, you always add it to the staging area and then commit it. And honestly, a lot of the time adding and committing can sort of be combined into a single step, especially for people sort of new to GitHub and programming. It's a lot easier to just think of them as one step of sort of saving a snapshot of your code. You know, it's sort of like hitting Control S as you're typing out an essay or something. It's just making sure that your progress has been saved and that you can go back to it if you need to. And so why you want to create this new branch is because you don't want to alter the master branch while other people might check out from it, while they might work on it themselves. You want to have a branch because that means that other people aren't going to be like interfering with your code. Like that branch could be entirely yours. So if you had a project team with 4 people on it, each of them could have their own branch. And that means that they could work on the code as much as they wanted without worrying about it affecting other people, which is really nice. So yeah, you'll be adding and committing changes as you need to your branch as you're writing like the update to your code. And if you need to, you can always revert changes on the branch because again, the branch is completely sort of your own space. You don't really want to add and commit to the master branch or revert it without sort of like talking about it with the people you're working on the code with. So once you're sort of happy with the state of your update, with the state of your branch, you're going to want to push your branch to GitHub. So that's an important distinction. You're pushing your branch to GitHub. So that doesn't mean that you're changing the master branch at all. You're just changing the version of your branch on the online repository to be concurrent with what the state of your branch is on your local repository. Be careful because you don't want to merge your branch to the master branch right away, as this could unintentionally cause conflicts with code that other people are writing. Instead, GitHub has a really nice feature that I strongly encourage people to use. I think it's generally just good practice, is to use GitHub's pull request feature. And this basically schedules a merge to happen, but allows people to sort of look over it and review it before it actually goes through, which means that if anyone has any issues, they can bring it up beforehand. And it just prevents, you know, a bit of confusion. So, and this pull request is really nice because basically the person who owns the entire repository can just look it over and either confirm it, you know, confirm that it gets merged, or just put a hold on the pull request and don't let it go through. So yeah, again, this 5-step process is pretty much a good workflow to go through. So, you know, check out the master branch and then pull from the online repository to keep it up to date, and then branch out. So either check out the version that you've been working on, or just create a new branch for the update you're working on. Fiddle over there, adding and committing stuff, reverting stuff as you need, and then finally pushing it to the online repository, and then initiating a pull request to merge it with the master branch. So this is a lot of talking, a lot of slides. So it'd be good to sort of show a visual representation of what's going on. And I'm going to do that with GitHub Desktop. So it's a tool that allows you to interact with GitHub from a desktop application rather than through a website or through a command line. And it's a really easy tool compared to just normal Git commands. There's still a bit to learn of it, but if you've sort of followed along with like the basic ideas of these slides, then it should be hopefully not too hard to learn how to use the desktop application. So you can sign up for GitHub an account just at github.com. Again, it's free, which is really nice. And a lot of people use it, which is great. And then, yeah, the GitHub desktop is just available at desktop.github.com. I would say what the advantage is of the desktop application is that it allows access to a few more features a bit more cleanly. Sometimes it can be a bit confusing to work through the website. Like you don't always have access, like reverting a change might be a bit more confusing. Editing a file might be a bit more confusing. And it's nice because the desktop application makes it very clear what's going on as you do things. Additionally, the desktop application is nice because it sort of directly interfaces with the local files on your computer. So you can just like, hypothetically, you could even make your desktop into a GitHub repository, and you could just really easily add and remove files from your desktop. But this could be any folder, so it wouldn't have to be your desktop. It could be your documents folder. It could be a file in your documents folder. But you could add and remove files from that really easily without, finagling with the website or like uploading or downloading files at all, which is really nice, especially if you want to use some sort of code editor like, say, for instance, like Atom or like BlueJ or something for Java, some sort of text editor that you wanted to use. It'd be easier to do that with the desktop application because the files are saved locally rather than on a website. On the website, you can only really use the GitHub text editor, which isn't great. Yeah. So when you first open GitHub Desktop, this is basically what it's going to look like. There will be a step to log in. So that would just be logging in with a GitHub account. But yeah, you can sort of see the different repositories that you have access to. You'll see that a couple of mine are private. They have the little lock next to them, so not anyone can see them. And then a couple of them are open, which means that anyone on the internet can see them. And you'll see some of the options on the left are some of the ones we've talked about. So like cloning a repository from the internet is an option, as well as just creating a new repository. So let's try that. We're going to have to give it a name. So let's just call it something like demo in a description. We'll also see where on the local file system it'll be saved to. So this is the exact file path to the folder. And if you know much about file structures, you should be able to locate where it is pretty easily. And this can be anywhere. I'm just going to say that I'm going to initialize it with a README. So it'll start with a file inside of it. Yeah, you can add a license if you want. This basically, this is like how other people are allowed to use your code. MIT license is pretty common. It's very permissive, so people can pretty much do anything with your code. So you can choose a more restrictive license if you want, but it's probably just fine to do an MIT license or no license at all, unless you're making a big project, of course, that you want that you feel protective of. So right now we're in the demo repository and we'll see a lot of options. So we'll see the ability to publish this repository to GitHub. So this basically means that we're gonna actually like, so this means that we're actually going to have the repository accessible through the GitHub website rather than just locally on our machine. But we only need to do that once is the nice thing. And at this point, so we're in the current repository demo 2. And there should be exactly one file in here. Well, actually 2. So the license and the README file. The README file I added as I initialized it, but any of your files that you had in here would just show up, as well as any subdirectories. So if you had folders within folders to like organize your code, this would all show up here as well. Yeah, you can just do stuff like open different files in different programs. So for instance, I can open the README file in the Atom. So it popped up on my screen. It's not showing on Zoom, but it basically opened a text editor. But you can also just edit it in here, I believe, if you'd like to. Perhaps not. But yeah. So yeah, actually, so I'm gonna really quickly open this in Atom and just type a really quick change on my end. So instead of having it say demo, I'm gonna have it say demo and then say this is a change. And I'm gonna just save it like I normally would save a file. So just Command S. And now when I look over in the Changes tab, it's gonna show me that I've actually updated this file. So I didn't touch this file at all inside of the desktop application. I just edited it with a normal text editor on my normal file structure, but it shows that the change happened. So this is sort of equivalent to Git status. It shows you the changes that have happened to the files. So one of the options I have now is I can commit this to main. So main is the current branch I'm on. Another common name for this branch would be master or origin, but it looks like this version is just called main. So if I was going to commit this change, I would give a title to the commit, and I would give a description. So I'm going to say changed README as the oops, change change the README, and in the description I'll just say added this is a change. Normally the descriptions would be a bit more succinct rather than just explicitly saying what was changed, but yeah, I'm going to commit this to main. So I've committed it. So this means that I have officially saved this progress that I've done to these files. And if I go to the history now, you'll see that it's officially become part of the branch history that I've changed README. So let's say, I'm feeling a bit lazy and I really actually don't want the README to say that. I could actually go back and revert to this commit. So basically by right-clicking on it, I could revert back to this and it would basically do the changes again. I would need to recommit it. So I'd just say reverted changes. And I could commit this. Yeah, so now I'll have reverted the changes back, which is really nice. Right. Right, so other things I can do is I can manage the different branches that I'm working on. So I did all of that on the main branch, but as we sort of like look at the workflow, that's not technically what you really should be doing. Instead, if I wanted to make a change, I should really make a new branch and just call it like, I'm just going to use my name, right, to make it really clear who's working on this branch. So I'm going to create a new Jamie branch. You'll see that the current branch up here is now Jamie. And if I wanted to, I could switch right back to that main branch, but instead, I'm going to be on this Jamie branch instead. So let's say now I go over to here and I go to, let's say the license. Let's say I wanted to open the README and I wanted to add a bit more to it. So this is my Jamie branch. So let's say I wanted to say, Jamie was here. So now I've edited this file. So we'll see the change shortly over on the desktop application. You can see it says Jamie was here. And let's say I commit that to Jamie. So marked my branch, I'll just call it. So I'm going to commit that to Jamie. We'll see it as part of the history now. But the cool thing is that if I go back to the main branch, you'll see that again, this isn't actually like part of the main branch. Instead, the main branch is still the way as it was, and it doesn't actually have the commit that says Jamie was here. I would need to go back to the Jamie branch, and now you'll see the change. So say, I was really happy with this change that I had just made to the README. I would basically want to create a new pull request. So you'll see this tab over here for pull requests. And basically, I'd want to go over to the master branch, or the main branch, and I'd want to choose a branch to merge into main down here. And I want to merge the Jamie branch. Because I own the repo, I think it just did it right away, but I believe there's a way to have it like manage it so it doesn't automatically merge it into it. So I've made a lot of changes to the local repository on here. I've created a new branch, merged it back into main, but this hasn't actually changed the server version of the repository. And you can actually see this up here that there's some stuff to actually push to the repository. So I'm going to do that right now. And basically what that's doing is it's changing what's actually stored on the GitHub website. So now if someone else on a different computer pulled from the GitHub website, they would have the Jamie was here tag on the README, just to sort of show it off. But yeah, so this is a useful desktop application. There's some features I'm not showing, but this is sort of the main stuff, with the different repositories. If you really want to, you can be working on multiple repositories at once. You have the branches that are inside of the repository, and then you have the ability to push and pull from the online repository, and then just revert changes and commit changes and stuff of that nature. But yeah, so I would highly suggest using a desktop application like this. I think this is a pretty good one to do. If you really wanted to, you could, instead of doing a desktop application, you could instead use it through a terminal or the website. So really quickly, I'll just show off the website itself. Yeah, so this will look a bit different from the desktop application. A few less features, but a bit cleaner to look at maybe. It's a bit easier to actually directly download files from their website, which is nice. A bit more intuitive to do. Yeah, so we can see this demo repository that I was just working on through the desktop application, and we can see the README with the text Jamie was here. We can see the different branches, although we didn't actually push the Jamie branch to the website. We only pushed the main branch. And so you push branches, you don't push entire repositories. So that's why we can't see the Jamie branch. But yeah, so we can see the different code in here on the website. But yeah, this isn't really necessarily where you want to be altering code. Like I said, there is like a way to edit stuff online, but it's just not the best. You'd probably prefer to use a text editor locally on your computer.